Alright, this is video number 2 for Honors Math 1 e-learning day on March 18th. Alright, so this is where we left off. I asked you guys to solve this systems of equations by using matrices. So again, we rewrote this two variable matrix as a matrix equation. Right. So here we see the solution. Right, so this is what you should have got. So again, we want to first find the inverse of the coefficient matrix. So again, we're going to use the determinant method of finding the inverse. So here is the determinant, value determinant is 2. Okay, so we're going to use that. So again, here's the notation for inverse. So again, we want to find the inverse of this coefficient matrix by using the determinant method. So that inverse is equal to 1 over the value of the determinant times this matrix, which again is the altered version of the coefficient matrix. We flip-flop the AD numbers. We want the opposite of the BC. Okay, so that's how we create this matrix. And we multiply 1/2 times this matrix to get this matrix. Okay, so this is the inverse matrix of the coefficient matrix. Okay. So once we have that, we are now going to take that inverse matrix, and we're going to multiply to both sides of this equation. So here, that's the next step here. So here's that inverse matrix multiplied to the coefficient matrix. Here's that inverse matrix on the other side, the equal sign multiplied by the solution matrix. So again, you can double check to make sure. Alright, but what should happen is that when we multiply the original coefficient matrix times its inverse, we get this identity matrix. Right? We should get 1, 0, 0, 1. Now, when you multiply these two, just to check, if you did not get the identity matrix, so that means that your inverse calculation was wrong. So you always want to kind of check. Don't, sometimes students assume that, alright, once they get this, that it will end up to be this. Alright, so if you have, I always talk about, right, on quizzes and tests, if you have time, you really do want to check to make sure, right, that you calculated this inverse matrix correctly. And if you did, you should get the identity matrix. Alright, so again, here when we multiply on this side, the inverse matrix times the solution matrix, again, we're doing row times column. Alright, always row times column. This is what you get, negative 12, 7. Okay, so we simplify that a little bit. We get this matrix xy is equal to negative 12, 7, which is basically telling you that the x value is negative 12, the y value is 7, and again, because we're solving the systems of equations, you know that we always have to write our answer as an ordered pair. So there's negative 12, 7. Okay. Alright, so that is it for the lesson. So what you could do as kind of a warm-up to get you ready for the homework is to maybe try these problems from the set. So here they're asking you to use the determinant of these 2x2 matrices to decide which systems have unique solutions and which ones do not. So again, basically, if you can find, if any of these, you convert these into matrices, and you take your coefficient matrix, and you want to see if you can find an inverse. So again, if you can find an inverse, if an inverse is possible, then that means you can solve these systems. Okay, so do this as a warm-up. And when you're done, again, check your answers on on Canvas. Go to the module answer key, check your answers for this part of the set. And then when you're done, then you can start working on the worksheet that is attached to the module. Okay. All right, so that's it for today. So if you guys have any questions, again, as always, please send me an email, let me know, and I'll get back to you as soon as I can. All right, you guys have a great day.